All right, so I'll share my screen. Let me know when you can see the screen. All right, so is the screen visible?
Yes.
No.
Okay, so we'll continue from where we left off last time. We were solving some of the past paper questions. I gave you some homeworks. I think I got from both of you, Taha and Muiz, I got the solved form of the worksheet. So that's good. I'll go through it after some time, and we'll discuss the entire worksheet in the class as well. I was hoping that we'll do it in today's class, but then I remembered last time we were solving some of the questions, and it's better to at least finish those questions, and then we'll move towards the worksheet, and then we'll start with the next chapter as well. So, is there any question from, even if it's from the worksheet, if there's something that you did not understand, you can let me know, or if there is any question from this the last lecture that we were doing. We were really solving some of the past papers, right? So any question?
No.
Okay, great. So we were doing this problem where we had two displacements, and we really only had to add these vectors, right? We had to add these two displacement vectors using the graphical method. So we did that. We stated the scale of the system. We drew this diagram, and we found the resultant as well. The resultant vector was found by simply drawing this vector and then using a scale to measure this vector. So all of this we have done in the last class, and to determine the direction, we'll just measure it with using a protractor. We can place the protractor on any of the horizontal line or this vertical line, but we'll have to specify from what direction are we measuring the resultant, right? So you just have to use the protractor, and I'm sure that we are all aware of how to use a protractor, and then you can just measure the angle. So either it could be this angle, or you could measure this angle, this one, right? And then you just have to specify that this is the angle from, for example, east of north or anything, right? So you have to specify from which point you are measuring the angle, right? So that's what we did last time. So is this clear? Is there any problem, anything that you did not understand in this question?
So it's clear.
All right, great. So we have two more students at this point, but Minhal and Arif Noshir. Okay, excuse me for pronouncing your names wrong. But okay, so these are the names that I'm seeing for the first time. This is your first class, right? Both of you, Minhal and Noshirwan.
Yes.
All right. So far we have really just finished the first topic, which was a very basic topic of physical quantities, units, and vectors, scalars. We went through the theory of that, and we finished that, and we moved on towards the past paper questions, and we were solving some of the past paper questions. Last time we left off with this question number 3. These lectures that you have missed, they can be found on YouTube Mega Lecture. Some of the lectures have been uploaded over there. In fact, I think all of the previous lectures have been uploaded over there on the Mega Lectures YouTube channel. You can find them as O-level live lectures. It would be named something like that, lecture 1, lecture 2, and so on. So you can, well, catch up to this point if you watch those lectures after the class. You can go and watch those lectures after the class as well. If you have any question whatsoever, feel free to ask me. You can WhatsApp me. you can WhatsApp in this group that we have any of your questions that you might not understand, as this is also your first class. So there might be, of course, I'm expecting there will be questions. Feel free to drop them in the WhatsApp group as well, right? Okay, great. So from this problem, there is no question, right? This is what we were doing the last time. All right, Urva has also joined us. Are there any questions? Urva, do you have any question from the last class?
No.
All right. Okay, so this was the problem that we were doing, and we really finished this problem. You can just determine the angles by using a protractor. So we finished with this problem. We'll now move on to the next one. Well, really the next part of this problem. And he says that another journey covers a distance of 700 meters. Describe how it is possible that this journey has no resultant displacement. So really you have another, you have a journey that where you can, you're covering a, is it possible that this journey will have zero displacement? Anyone from the class? It's just a one mark question, really.
They are traveling in a straight line.
They are traveling in a straight line. So, I mean, that is, well, you have to be kind of more specific, because in this case, I can say that there is some displacement if I'm going from this point A to point B, right? The displacement vector is still there. So really traveling in a straight line is, you could have also said it this way: the shortest distance between these 2 points is a straight line, which is defined as displacement. But the question is, how is it possible that this displacement vector is zero? Or is it even possible, or is it not possible? Anyone from the class? How would the nature of my journey be that would imply that the resultant displacement is zero? Anyone? Okay, so it would really be the case, for example, you are starting your journey from some point A, and then you go around and do whatever the hell you want, really, and you come back to this point A. In this case, you started your journey from point A, and you're coming back, your destination is still this same point A. So if I were to draw a displacement vector from this point A to point A, that would just look like zero, right? Because if I say that this is my, or let's just do it over here. So this is my point A, and I want the shortest distance from point A to point A, but that's zero, right? So that's displacement. So the only way that your resultant displacement can vanish is if I'm starting and ending at the same point. So is that clear?
Yes.
Right? Okay, so it's clear for everyone. Everyone understands the concept behind a zero displacement. All right, so I'll assume that everyone understands it. If you have a question, you can ask me. We'll move to the next problem. Okay, so you can see that we have this problem, question number 4, and the problem statement is that we have a bus and it breaks down on a road with a 10-degree upward slope. So this road, really, if I draw a horizontal line like this, it is at about 10 degrees on a slope that is upwards from this reference line. Now the bus breaks down, which really means that it's not going to move anymore using the mechanics of the whatever how the engine of the bus really stops. And now you will have to push the bus on the slope in the upwards direction. So the passengers get out and they push the bus to the top of the slope at a constant speed. So they're going to push the bus and the bus moves with some constant speed. We can see in this figure what is happening. So there the passengers are applying a force to this bus, and you can imagine that this force vector, if I draw this in the form of a vector, it would look like this, right? So this is the force vector that is being applied, which is parallel to the line of the slope. So they're telling you in part A that the total mass of the bus is 3,200 kilograms. This is the mass of the bus. Calculate the weight of the bus. How would you do that? So we know weight is mass times the acceleration due to gravity, which is g. And we know that the value for g is just either you can take it 10 or 9.8 meters per second squared, while the mass of the bus is 3,200 kilograms. So this gives you 32,000 kilograms meters per second squared. But this unit is called newtons. So that's 32,000 newtons. So that was simple, right? Anybody has any problem in this part of the question?
Can you explain it again from the?
Right. So we are really in this point, we are given the mass of the bus and they're asking you what would be the weight of this bus. Weight is something that is, you can have consider this bus to be a point mass, and the weight is just a vector that points directly downwards from any object, right? So it is, any object will have a weight if there is gravity acting on it, right? So for example, you would also have a person has a weight, and it's just the weight is really what is keeping this person to the center of the earth, which keeps you your weight. So the higher the weight, higher your weight is, the more difficult it would be for you to get across or move anywhere. Because if your weight is high, that means your mass is a constant, right? It's not going to change. So for example, the mass of this bus will not change after some time. It's going to be a fixed constant. But acceleration due to gravity, which is g, this thing, g is equal to 10 meters per second squared. This value really depends on the mass of the planet or mass of the earth, for example. And in on earth, the value for acceleration due to gravity is 10 meters per second squared. This g really is the acceleration which is keeping you on this surface of the earth. The less this value is, the easier it is for you to escape the surface of the earth. So for example, on moon, this value is less than 10 meters per second squared. So when you jump on, if you would jump on a moon, it would take some time to come back to the surface. However, on earth, it also takes some time, but on moon, this time would be relatively more, because the force, the gravity, this vector g, acceleration due to gravity, is less on the moon. So it's an acceleration, right? So if acceleration is less, then your velocity would change slowly. So I'm just going into many details at this point of this thing. It's not the understanding gravity at this point is not the topic. So you can just compute the weight if you multiply the mass with this quantity, which is known as the acceleration due to gravity. And on Earth, its value is always approximately about 10 meters per second squared. So all you have to do to compute weight is multiply your mass with this value on Earth. Now you can see that the weight of any object would be different on different planets, for example, because you would have, for example, on Earth, this is the value of G. On Mars or maybe on Moon, the value of G would vary. It would be different. And so the weight on different planets, you would have different weights, but the mass will not change. Your mass is still the same, but the weight will vary depending on what is the value of this G. So all I have to do to compute the weight is multiply by mass with the acceleration due to gravity, which is on Earth 10 meters per second squared. So all I have done is multiplied this 10 with this 10. So that's clear, right?
Yes, clear.
All right. Okay, so now the next part says on figure 10.1, which is this one, draw two arrows to show the direction of the weight of the bus and the direction of the force exerted on the bus by the passengers. That's something that I have already drawn, right? Reading the question statement. So the weight of the bus will be an arrow which points directly straight down in the downwards direction, right? So this is the weight of the bus. And the force on the bus by these passengers is in this direction, right? Because they told you, you can just, if you look at this figure, it's very clear that the force is in this direction by the passengers because they're pushing it along this line, right? So that's the force vector and that's the weight. So is that clear?
Yes.
Okay, so it's clear for everyone? Everything that we have done so far to this point?
Yes.
All right. So next, we have this thing where you have the total force exerted by the passengers on the bus is given as 17,000 newtons. So they have given you a value for this force, and they're saying that it's 17,000 newtons along the line of the slope. Use a graphical method to determine the size and direction of the resultant of this force and the weight of the bus. So you want to find a resultant vector which you get from this vector of F and this vector from W. Now we know that the force vector is going to be like this, while the weight vector is going to be like this. And so if I were to draw it using a graphical method, I want you to tell me, how would I draw the force vector, for example? Would it be something like this? Is this the correct force vector?
Yes.
Right? Okay, good. Because all you have to do is take this vector that you see upwards, this one, and just draw a vector like this. And then for the weight, I have no idea what happened. Did everything really shifted a bit upwards, right, on the screen? I don't know how that happened, but yeah. So this is the force vector, and the weight vector would be directly downwards, right, as we drew over here. So it's directly downwards from the bus. So that's how the weight vector would look like. So at this point, all I'm doing is I'm just drawing these vectors over here on a simple plain paper. Now, to draw this diagram, remember what was the first step in drawing vector diagrams like these? Graphical method of finding the resultant vector. What is the first step that I have to do?
Move the force.
Selecting a scale.
Okay. Sorry.
Selecting a scale.
Yeah, exactly. So we'll be selecting the scale, right? So the first step is always to write down a proper scale for your vectors. Now, we know that the weight of the bus is, this value is 32,000 newtons, while force is almost, it's actually given, it's 17,000 newtons. So in your opinion, looking at these two vectors, what would be a proper scale at this point? What scale can I use saying that this much force is equivalent to these many centimeters, or this many newtons is equal to this many centimeters? One choice would be saying that 1000 newtons is 1 centimeter. But in that case, we can see you'll have to draw a line of 17 centimeters for this force and a line of 32 centimeters for this weight. Now, I mean, even though that might be almost possible, but I don't think it's a suitable scale to use when drawing on a piece of paper, which is an A4 size paper. So a better scale could be using 10,000 newtons as 1 centimeter. So this scale might be better compared to 1000 newtons as 1 centimeter. So in this case, all I have to do is draw, for this force, I need to draw a line which is of 1.7 centimeters. And then for weight, I'll just put the tail of this vector on this head of this force vector, and the weight would be a line of 3.2 centimeters. Is that clear for everyone?
Yes.
Okay,
Where
good.
did the 1.7 come from?
Oh, from this 17,000 newtons. You might, or are you asking where did this come from? 17,000.
No, I know where that comes from, but where did 1.7 come from? Did you divide it by 1,000 or something? 10,000? I don't know.
Oh, it's actually 17,000. Oh, okay, my mistake. It's 17,000, right? So if I divide 17,000 by 1,000, actually not my mistake, but if I divide 17,000 by 1,000, what do I get? I'll get 17, right? And if I divide 17,000 by 10,000, then I'll get 1.7. So I just converted this newtons into centimeters by dividing it by 10,000. Was that the question?
Yes.
Okay, so it's clear?
Yeah.
Right, good. So that's how you got 1.7, and in the same exact fashion, you can write 3.2 centimeters for 32,000 newtons. So is that clear?
Yes.
All right, great. So how can I draw a resultant vector for these two vectors? From where should I start and where should I end this vector? Anyone can tell me, what do you think? How should I draw this vector?
We should probably draw a line joining both of these vectors.
Right, so where should I start from? Should I start from this tail?
1.72, yeah.
Yeah, okay, so I'll start from this tail and I'll end at this thing, right? So this would be the resultant vector of these two vectors. And then all I have to do is take a ruler, scale, whatever, and put it at this point and at this point, and then measure the length. I'll get something in centimeters, and I'll use this scale to write those centimeters in newtons. And that would be the resultant force, right? So, I mean, I don't have a scale at this point, so, but I hope that the method is clear, right? So is this clear? How can I find the resultant vector? Do you understand how we'll find it in centimeters, and then we'll use this scale to convert it into newtons, and then we'll write it in newtons? So is that clear?
Yes.
Yes.
Okay, great. And then similarly, you can use a protractor and write the angle for this vector as well. So if I draw, for example, I draw a reference line which is horizontal, I'll place a protractor on this line, something like this. Okay, never mind. Okay, so a protractor is something like this, right? You'll place it like this, and you'll start measuring this line, and you'll say that the resultant vector is this many degrees from horizontal, whatever value you get from degrees over here. So is that clear? And then you'll just obviously write down the scale that you chose. The size of the resultant is this value for r, and the direction of the resultant is this angle theta that we were finding. So is that clear for everyone?
Yes.
Okay, great. Now, there's this very small part. It says that the bus travels at a constant speed. So the speed of the bus is constant. That's actually a very important point over here. State the size of the resultant of all of the forces which would be acting on the bus. So the resultant of all of the forces, so that the speed of the bus is constant. What should be the resultant force in this case with constant speed? Anyone? The stress is on this point, constant speed. What does it mean if their speed is constant?
I think it would be 0.
Yes, exactly. It would be 0, right? Because any reason for that thought?
Because there is no force acting upon it.
Exactly,
It's
right?
just going
So
straight.
yeah, so when there is no force acting on something, then the speed remains constant, because force is mass times acceleration, and obviously the mass of the bus cannot be 0, right? It has a mass. There is some mass. So acceleration is 0, which because of that the force is 0. And if acceleration is 0, it means that the change in velocity is 0, right? Because acceleration is change in velocity by some change in time. Now, of course, time is not 0. Change in velocity is 0, which means this thing is implying constant speed, right? Because there is no changing velocities. So is that clear for everyone in the class?
Yes.
Okay, great, good. So let's move on to the next question. Okay, for some reason, this is very slow. Okay. All right, so here, can you see this next question? Question number 5. Is it visible for everyone?
Yes.
All right. So here we have a question that says that the diagram shows 3 forces acting on a block. So here we have a block, and there are 3 different forces on this block. Which additional force? So I need another force on this. will produce a resultant force of 3 newtons to the left. So the question is simply asking you what and where should this additional force should I draw so that the net of all of those forces will be in this direction, right? And it would be of 3 newtons. So that's the net result that I want. So what should be the result, the additional force on this block? Do you understand the question?
Sir, can you explain again?
Yeah. So basically the question is saying that you have a block and already there are 3 forces in this way acting on this block. 11 newtons to the right, 3 and 2 newtons to the left. They're asking you, what is another, if I add another force on this block, in which direction and of what magnitude should that force be, so that when I draw that force on this diagram and then I add all those forces, I get a net result of 3 newtons in this direction. So is the question clear? If it's if it's not clear, you can always let me know. I'll explain again.
Yes,
No problem.
the question is clear. Can I answer?
Okay, yes, of course, go ahead.
Is it C?
It's okay, so what would be your reasoning behind 9 newtons to the left?
Uh, 3 plus 9 plus 2 is equal to 14, and 14 minus 11 will equal to 3 Newton.
Okay, right. So that's absolutely correct. So does everyone understand what happened?
No, could you explain that again?
All right. So Taha, you were absolutely right. But how I recommend to go about the problem is always by defining your coordinate system, by which I mean, say that now you're defining that my right is positive and my left is negative. Once I choose this thing, then I can easily solve this problem, because this would mean then 11 to the right is just plus 11. And then 3 to the left is minus, I'll just add these units as well, right? Plus 11 Newton minus 3 newtons, because you see this is to the left, and then this is also to the left. So minus 2 newtons. And this gives you, let's just check, what does this give you? Once you do this, what do you get? 11 minus 3 is 8. 8 minus 2 is 6. So you'll get 6 newtons, right? Did I do the math right? Sometimes I don't even trust myself. So I'll just, yeah, it's 6 newtons, right? So now I don't want, now I want to add a force on this object, which would make this 6 newtons actually 3 newtons. In fact, it would make it minus 3 newtons. So how can I, what force should be on this object so that this thing becomes minus 3 newtons? So I'll just choose the right answer over here, and I'll